nitrogen, and science.
This video will teach you what are esters, how can we make the esters, what is the naming system of esters, molecular and structural formula of esters, and then we will see the uses of esters also. Esters are the homologous series having COO as a functional group. When we say COO and a dash both sides, that shows that there should be some R group on one side of the carbon ester, and the other side also has some carbon chain. These will include an ester in the sense that when we say there is a carbon chain on the both sides which is denoted by R, then the COO group actually is one C double bond O bonded to a single bond O and then another R. This is the actual structure of COO group of the ester. That is one carbon and two oxygen surrounded by the other carbon chains. Now in our video of carboxylic acids, we had seen that one of the important reaction of carboxylic acid is that carboxylic acids reacts with alcohols in the presence of acid catalyst to form the esters. Now that shows that both the carboxylic acid and alcohol are needed to make the esters, and acid, any dilute acid, is a catalyst. So making of esters in detail with carboxylic acids and alcohols we'll learn in the later part of this video. But before that, let's go ahead with the naming of the esters. Now when we say esters are made from carboxylic acid, suppose we say ethanoic acid is used. Ethanoic acid is used, and an alcohol, say methanol, is used. This is the acid and alcohol which we are using to make an ester. Then what will be the name? The name of this ester will be depending on the type of acid and alcohol which we have used. Now in the naming, remember the naming of the esters starts with the name of the alcohol. So suppose if we have used methanol, the name of the ester will start with methyl group. Methyl, because methanol is used as an alcohol. It is followed by the name of the acid. Now here if we have used ethanoic acid as an acid to make the ester, then the name following the methyl will be ethanoate. Now we know that any of the salt or compound made from acid have a naming of ate. So here if ethanoic acid is making a compound, we name it as ethanoate. So methyl ethanoate is the ester made from ethanoic acid and methanol in presence of the acid catalyst. So the naming of the ester depends on the alcohol and the acid used. Let's take another example. Say propanoic acid is used. Propanoic acid is used as a carboxylic acid, and then suppose if we say use ethanol as an alcohol, then what should be the name? As I said, the naming starts with the alcohol part. So our ester will start with the name ethyl from the alcohol part, and the acid used is propanoic acid. So ethyl propanoate is the name of the ester made from propanoic acid and ethanol. So this way I think name of any of the ester can be made, or from the name of the ester you can make out which alcohol and acid is used to make this ester. Now from the name, let's understand the structure of these esters also. Say methyl ethanoate. So if we know the structure of methyl ethanoate, then let me first write methyl ethanoate. Now if I am writing methyl ethanoate, what's the structure? In the structure again the acid should be drawn first. So here if the acid is ethanoic acid, let's start with the 2 carbon of the ethanoate. So this is the acid part, remember, and acid as we know have a double bond O in it. So Let's first complete the structure of acid, that is ethanoic acid. This is ethanoic acid where I add the remaining hydrogen. This is ethanoic acid that is reacted with methanol, methyl ethanoate, where methanol will be used as an alcohol. So methanol is CH3OH. Now if we draw the ester made from ethanoic acid and methanol, that is methyl ethanoate, in the ester the acid part should be drawn first. So I am drawing the acid part first. Now one should remember that this reaction is a condensation reaction. Condensation reaction because water is produced as a byproduct, or you can say water is eliminated from the ethanoic acid and alcohol. So how is water eliminated? The OH part of the ethanoic acid is removed and H of the ethanol is removed, forming the water. So this is how the water will be eliminated, and the remaining part of the acid and alcohol is going to bond to each other. So after removing the OH part, the ethanoic acid is drawn this way. Now reverse the alcohol from this direction to this direction and add it here. So I'll draw the O first here from the alcohol part, the O of the alcohol, and then the remaining carbon chain. So the remaining carbon chain has only one carbon, and this is how we get the structure of methyl ethanoate. So in the structure, remember, draw the acid part first till C double bond O, remove the OH of the acid, the H of the alcohol, reverse the alcohol and join it with the acid part, and this makes the ester of acid and given alcohol. And the COO part in between the molecule is the functional group of the ester, or you can also call it as an ester linkage. So this is how you make an ester. Let's try with another molecule. In making the ester, we had also seen ethyl propanoate. So let's make ethyl propanoate from propanoic acid and ethanol. So making ethyl propanoate from propanoic acid and ethanol in presence of any dilute acid like sulfuric acid, which is the most common acid used as a catalyst here. So we will get ethyl propanoate. So if we draw the structure of propanoic acid, it's 3 carbon in chain. So 3 carbon in chain with double bond O, single bond O and H. So this is propanoic acid, and then let's complete the 4 valency of each carbon with the hydrogen. Let's draw the ethanol with 2 carbon and the OH, remaining valency of carbon, that is 4 covalent bonds of carbon is fulfilled by adding hydrogen, remaining hydrogen. Now if we draw the ester structure from this, dilute sulfuric acid as a catalyst. Now as we have already learned that the acid part is drawn first. So let's draw the acid part with the 3 carbon chain first. The third carbon has a double bond O, and the 2 carbon with the remaining hydrogen with no change. The remaining hydrogen are drawn without making any change. Now as I said earlier, the OH part of the carboxylic acid is removed and the hydrogen from the alcohol is removed to make the water as a byproduct, it being a condensation reaction. So now join the alcohol part to the acid part here to make the remaining part of the ester, and we'll start by writing O here with the carbon. This O part is bonded to the carbon of the carboxylic acid, and then the remaining part of the alcohol with the 2 carbon. So we have drawn 2 carbon ethanol for the remaining ester structure, and this is done. So this is the structure of ethyl propanoate, and this is how you make the structure of any of the ester, or from the name or the structure of the ester you can make out which acid and which alcohol is used to make this ester. Any part, the first one or the reverse one, is very easy to understand, and the in between part COO is the ester linkage, or that's the functional group of the ester, eliminating out water. Esters are very simple compounds with a very good uses. Say many of the esters have attractive smells and taste of many fruits. So that is the reason that they are added to the shampoos or soaps for their smells, or even they are added to ice creams or other food additives to give the flavor of any given fruit or flower. For example, if we want to add a flavor of apple to the ice cream, or pineapple or strawberry, a distinctive ester is added to get that flavor. For example, if propyl ethanoate is added, it will give a smell of pears. If ethyl butanoate is used, it will flavor or it will smell like a pineapple. Pentyl ethanoate smells like a banana. So different fruits or flowers can be added in the food flavoring with the help of esters. So these esters having a very simple structure but has a very good use.